Welcome viewer, my name is Daniel Ndungu from SOS Technical Training Institute, and you are watching at history. We are continuing on our series on electrical installation, and we are going to continue from where we left on electrical safety. We have seen that we need to reduce the risk of electric shock, and we do that by ensuring that we have our system, and we also use correct fuses and circuit breakers. We have seen that when we do earthing, we ensure that all electrical appliances, the metallic part and all the metallic part of the installation remain at zero potential. And if we use the correct fuses and circuit breaker, we ensure that we don't expose our metallic part that is generally earthed to any risk that there would be a rise in potential that would result to an electric shock. The other thing that we need to note for electrical safety is on correct cables. And when we are talking about correct cables, definitely when you go to the installation, you find that an electrician, a qualified electrician, has already done the wiring, and he has used the correct cables. But sometimes there requires a need to do an extension of the installation, maybe to do an additional load. And this most of the time is done by people who are not qualified, because you feel that I just need to get a cable, plug it to the socket and extend my socket. But that should be done when you bear in mind that you are using the correct cables. This is because when you go to electrical installation, cables come at different sizes. We have sizes. We have sizes that is as low as 0.5 millimeter squared to one that for domestic we go up to 6.0 millimeter squared. Now there is a reason as to why we have these cables and why they are rated as such. The cable that is rated at 0.5 millimeter squared and the cable that is rated at 6.0 millimeter squared, there is of course a difference, and the difference comes when we do current carrying capability. Or current carrying capacity, let's call it. The difference is on current carrying capacity, whereby a cable of 0.5 will not be able to handle as much current as that one of 6.0, and this is something that should be noted. Other than the size of the cable, there is also the fact on insulation. And we are talking about quality of the insulation used. We find that some cables are supposed to operate at a voltage maybe less than 50 volts, and there are those cables that can operate to up to less than 300 volts. And it goes up to that. For domestic, you expect this will be the highest voltage that will be operated on. But in the market, we have so many cables that are supposed to be used for voltages less than 50 volts. And one of them would be the speaker wire that is commonly used. But unfortunately, majority of the people continue to use that wire for doing extensions at home, and that is very risky, because the quality of the insulation would be that that cable is only designed to operate at voltages less than 50 volts. So when the voltage exceeds 50 volts, the quality or the quality of the installation is no longer guaranteed, because it might be exposed to higher electric field, and those electric field would result to the insulation breaking down. Insulation breaking down. Breakdown. Insulation breakdown, and when the insulation breaks down, it results to a short circuit. And when we have a short circuit, there are chances that if the protection or the protecting devices are not able to operate within very fast, then we are likely to have a fire. If a short circuit is not arrested, the end result is normally fire, which is quite destructive and dangerous. So because of these risks that we are seeing here, it is important that if you want to do an extension and you are not even a qualified technician, please you either get proper information on the cables that you are going to use, so that you use cables that have both the current carrying capacity and they have the proper quality of the insulation for the work that you want to be done. Now in Kenya, our main supply, we have 240 volts. They are rated at 240 volts AC. Now, if you use a cable that the insulation is only guaranteed up to 50 volts, then you are exposing yourself to this insulation breakdown and probably a short circuit. And if the short circuit is not taken care of, then the risk of fire is quite high. So that's what we have. So this goes a long way to give you an insight that the risk that you're exposing yourself to. Now let's go to the correct cables. Now you find that all electrical equipment are rated at they are rated in watts. And last time we said watt, this is the rate of doing work. And when we have an equipment that is rated at watts, it is possible to do a simple calculation and get all the other parameters, because power is given by IV, and I, this is current, and this is voltage. So the product of the two is what gives us power, or the ability or the quality or the rate at which work will be done by that particular circuit. So what happens is that if you get an equipment that is rated in watts, then it is possible to calculate the current, because the current is key, because definitely it dictates the cable that you're going to choose there. So for example, if you have an electric kettle rated at 200 2200 watts. It's possible to calculate the amount of current that will be drawn by that equipment, and you simply you take the power, that is the watts, 2200 watts, you divide by 240 volts, because this is our supply, or this is our mains, and simple calculation, that one goes by 2 by 4 6 by 4 5 and get 9 point. Around 3 there amperes. So this is the current that will be drawn by this equipment, and what you are supposed to understand is that if this is the current that will be drawn by that equipment, you are supposed to note that this cable might not be enough to give that amount of current. For this amount of current, you need a cable that is at least 1.5 millimeter squared. That is the cable that you need. And if you use a cable that is less, what you get is that the cable is heating. If the cable is heating, then it means that that cable is not able to carry the amount of current, and the heating is due to this. The heating is due to I squared R, and of course, if the cable now is carrying this, and even if you assume that the resistance is quite low, and you square this, you get that the amount of heat that will be given by that cable becomes very high, and it can be dangerous. Now, this cable heating, if you get the cable that is heating, then it means that the work that you want done by this heater will not be done, because the amount of power that will be drawn from the source will not be enough to give what you need, which means that you spend more time, and of course you get frustrated, and of course you waste some power on this. You waste some power on this, and this is something that we don't want to see, because we need work to be done, and work to be done efficiently. So that's what must be realized. Now, if, for example, you want to do an extension, and probably you are a farmer, and you want to maybe add something like a shaft cutter or a water pump, it is always good. Do not attempt to do these things at home. Please consult a qualified technician, so that he or she advises you on the appropriate cable size that would be able to do your work and do it better, so that we don't have this waste, because this one goes as waste. This is waste. Energy that is drawn, and it is not doing any useful work, and we refer to as that waste. So that's what would happen. So the other issue is on the quality of the insulation that might be chosen. But this one has no much problem, because most of the cables that we use for domestic installation, most of them are rated at 300 volts, which is quite safe to compare our 240 volts that we use for our domestic installations here in Kenya. So that one has no much problem. But on the quality, on the size of the conductor, that's something that should be noted very well. Like now, if you want to supply maybe a shower unit, that that you don't know the rating, then the best thing you do is probably get someone who is able to do that. Because if you get a shower unit that is rated as, because some of the shower units are rated as high as, which means that if this is the rating, then and you divide this by 240, you get that the cable required might not be this. Might go to 4.0 millimeter squared. So that's what should be understood. Plus, sometimes even if you are in a complete installation where all the final sub-circuits have been fixed and you want to put an additional load, it is always good that instead of adding on the installation that is already there, do a different circuit so that you are able to feed on the load that you want without any problem. And with that, will be of course will be more safe than what we have here. Now, to summarize what we have done today is that we have added two other safety concerns that are of important to us. One, we have seen on correct cable size and the insulation, because we have seen that these are things that affect the performance of equipment, and they also greatly affect the safety of our domestic, or the safety of the installation. So, and with that, we come to the end of our presentation today. I was your presenter, Daniel Ndongo, and stay tuned till next time.